morning. This is Nas from NB Network Lessons. Hope everyone is doing okay and in high spirits. Thank you for joining. Today's lesson is physics with algebra, lesson number 3, and we're going to discuss laws of motion. I'm going to introduce you with first law of motion and second law of motion by Newton. I have it written it down on the board. Newton's first law. Basically what it states is that if a body is at a rest, it will stay at rest, or if a body is in motion, it will stay in motion unless an unbalanced force stops it. Okay? That unbalanced force can be friction, that unbalanced force can be air, pressure. So basically what Newton was trying to say is that, like I explained in my earlier lecture, if you have a ball, okay, let's say you have a, you go to a bowling alley and you have a track. Let's say that you have a never-ending track and you basically toss the ball. That ball should keep on rolling forever unless there is friction on the track or air pressure, which stops it. So that is basically first law of motion from Newton. So again, if a body is at rest, it should stay at rest. If a body is in motion, it will keep rolling until and unless an external force stops it. That's the first law of motion. Second law of motion. Basically, second law of motion says that if you apply a force to an object, let's say I have an object right here, this pen right here. If I apply force to this object, this pen will roll, okay, and accelerate. The more force I apply, the more acceleration. So he came up with this formula: force is equal to mass into acceleration, okay. So this force can produce motion, but it depends. So basically force is directly proportional to acceleration. The more force you have, the more acceleration you will have. However, it depends on the mass also, okay? So let's say if you have a ball which has very less mass, weighs maybe, 1 ounce or 2 ounces. You roll that with the same force, it will go much farther, okay? However, if you want a heavy ball, like a bowling alley ball, to go to the same distance, all right, you have to apply more force to it for it to basically reach wherever the ball with less weight reached. So make sense? So that is why we have force is equal to mass into acceleration. Now another thing which I would like to introduce you is gravitational pull, okay? It's 9.8 meter per second square. So this is basically, if you throw a ball or if you throw anything from a high-rise building, it comes down because of the gravitational pull by Earth, and it's 9.8 meter per second square, or 32 feet per second square. All right. So another thing, interesting thing is that if you go on moon, the gravitational pull is less. Okay. That's why when you see the space crew, when they go on moon, they wear heavy dresses and heavy uniforms, because over there their weight decreases. Okay. If you take the same ball and go up to the moon and toss it up in the air, it'll come back at a slower speed down, because moon has less gravitational pull. Earth has more gravitational pull. So that's what I wanted to discuss. So let's say this is Earth right here, okay? And then this is moon, okay? Earth has mass m1, moon has mass m2, right? Now question is, Earth and moon, there is a force which is attracting both of them, right? You agree with that? There is force between moon and earth which is basically attracting each other. The question is, why doesn't moon just hit the earth? Because earth has more mass, moon has less mass. Why doesn't it just hit the earth? Well, one thing we have to remember, moon is in a circular motion around the earth, okay? That motion basically compensates or basically negates for the force which with earth is attracting moon. Very interesting logic. You know, if moon is still, earth is still, moon would be attracted and hit the earth. However, Mother Nature came up with a system that moon is basically rotating around earth with certain force, and that force basically prevents moon to hit the earth, okay? And the formula we have is basically this force between earth and moon depends on G, which is the gravitational pull, m1 mass of earth multiplied by m2, okay, over r square, okay? R is the distance between moon and earth, okay? So if you have more distance between earth and moon or any two objects, okay, then what will it do? It will basically, if you have more distance, then what you will have to do is it will basically reduce the force, because this number is going to get big. Then you apply more force. So if two objects which are closer, okay, you have to apply less force for them to hit each other. If they're far away, you got to apply more force. So that's what it is. That's what it's saying. So Einstein also talked about this right here, function right here, and he's the one who came up with this analogy that the reason moon does not hit earth is because it's rotating around the earth. So that's all I wanted to talk about in this lecture. I will come back and we will go over motion, force, energy. I want you guys to stay energized, okay? I want you guys to stay energized. And if you have hunger to learn physics, this is the place for you. Thank you so much. Bye.